Lesson 4, Fractional Exponents. So recall from grade 9, remember that, when multiplying exponents with the same base, you can add the exponents. So, for example, if I have a to the power 4 times a to the power 3, that just turns into a to the power of 4 plus 3, which is just a to the power of 7. Okay, so if that's true, let's consider this one right here. If I say 7 to the power of 1/2, and you don't know exactly what 7 to the power of 1/2 is, but just follow me along this trail, okay? If I have 7 to the power of 1/2 plus 7 to the power of 1/2, that just means that we're going to add the exponents. So 7 to the power of 1/2 plus 1/2 is going to be 7 to the power of 7 to the power of 1, which is just going to be 7, okay? But if I have the square root of 7 times the square root of 7, square root of 7 times square root of 7, that's just going to be 7. Okay? Because two numbers, the square root of something, if you multiply it by itself 2 times, you get that original answer. Just side note, if I were to say the square root of 25 times the square root of 25, the square root of 25 is 5, times the square root of 25, which is 5. 5 times 5 is 25. So if you multiply 2 square roots together, you just get the argument, or the radicand, the thing that's underneath the square root, okay? So that means that if square root of 7 times the square root of 7 is 7, and 7 to the power of 1/2 plus 7 to the power of 1/2 is 7, that means that the square root of 7 is the exact same thing as 7 to the power of 1/2. So we can express this in 2 different ways. We can either have the square root of something, or we can have a fractional exponent. So to change a fractional exponent into a radical, okay, that square rooty thing or that rooty thing, the denominator of the fraction becomes your index, and the entire radical is then raised to the power of the numerator. And I just want to remind us, there is an implied 2 right here, the implied index of 2. Okay, we just don't write it because it's the most common one and we see it all the time. But the square root, if you just see that radical sign, it's 2. The index is 2. So, for example, I'm going to say that the 9 to the power of 1/2 is going to be the same thing as 9 to 9, the square root of 9, or the radical with an index of 2 raised to the power of 1. I'm just going to use my highlighter here to see where you get these numbers, okay? So I'm going to zoom in here. So I'm going to see this guy right here. I'm going to maybe not use my highlighter. This guy right here, this 2, matches up with this 2. This 9 matches up with this 9. And this 1, we don't write it all the time, but because we don't need to, because anything raised to the power of 1 is just itself. But this 1 is the 1 in the numerator becomes the 1 that the 9 is raised to. Okay, so that means that 9 raised to the power of 1/2 is the same thing as a square root of 9, which is just plain old 3. Let's try this one out. So the 81 goes underneath the radical. The 4 in the denominator becomes the index. And the 1 here, this one is just 81 is raised to the power of 1, and we don't need to write it out. So what number multiplied by itself 4 times becomes 81? Well, 3. Because 3 times 3 is 9, times 3 is 27, times 3 is 81. If ever you come up against decimal exponents must be changed into fractions. So if we get 36 to the power of 0.5, we say that is 36 raised to the power of 1/2, okay? And it doesn't tell us to evaluate or anything like that, but that is the same thing as the square root of 36, or the second root of 86, which is just plain old 6. What about this one? 32 to the power of 0.12. So let's get into its simplest form, 2 over 10, but we know that that can be simplified to 1/5. Okay. So that means that 32 to the power of 0.2 is going to be 32 raised to the power of 1/5. And if we were to evaluate it, underneath the radicand goes the 32. Okay. The index becomes 5. And the numerator is 1, so this is just raised to the power of 1 like this. So what number multiplied by itself 5 times gets to 32? 2, because 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. That's 5 times. When simplifying, more complicated fractional exponents, you can choose one of the two different ways. Okay, so we have 2 methods. In my method, the first one makes sense, but for other people, you might see this as something different. Okay. So when I see the 3, I know that underneath I know that the index on the radical is going to be a 3. And I see 125 as my base, so that becomes my radicand. And then 2, most of these have been 1, so 125 raised to the power of 2. So for me, this makes kind of makes the most sense. But it's harder to do mental math with this one. But where the placement of all of the different aspects of the fraction make a little bit more sense. So this is saying the third root of 125 to the power of 2. Well, 125 to the power of 2 is 15,625. Then we can use our calculator to figure out that the third root of 15,625 is just plain old 25. Make sure that you know how to use your calculator to find out what third roots, fourth roots, nth roots are. Okay, and if you don't know, please call one of us over. The second way that we can do this, and this is actually a little bit more friendly on the mental math part, I can say that the radicand, or the argument, the thing that's underneath the radical, is still going to be 125. And the denominator is still going to be that index. But what we can do instead is we can say that the cubed root of 125 is raised to the power of 2. So I can do this in my head. The third root of 125 is simply going to be 5. Okay, because 5 times 5 is 25, times 5 is 125. So I've just done what's in the brackets first, and then I'm going to raise it to the power of 2. So that becomes 25. So the second version is a little bit easier for your sweet mental math skills. You can strengthen those using the second one. The placement of where that 2 goes for me is easier in the first one. But you know, it's always great to strengthen our mental math. So then when writing radicals as fractional exponents, what we have to remember is the power of the radicand becomes your numerator. And the index of the radical becomes your denominator. So the base is 5 because that's my radicand. The index is my numerator, so that becomes a 4. And it's raised to the power of 3, so that becomes my numerator. Okay, and then this one is a little bit more simple because there's no, this one is a little bit more simple because there's no raising to the power of underneath the radicand. I'm just going to say my base is my 6. And then my denominator is my 3. And if there's a blank spot, it's 1 because 6 is raised to the power of 1. So we can just put that there. All right, so now what you find folks can do is you can go to your textbook and start working on those practice questions.